Hi everybody. I decided to do a little bit more work on my OpenGL with C++ series, and you'll notice here that we're in Visual Studio. I just felt like doing it. For these videos, I'm going to be looking at techniques that modern game engines use in order to display really big scenes. Some of this will be recounting stuff that I've done in previous videos, but hopefully it'll still be interesting. So here's the sort of situation that I've got. We can call this our baseline. Here I have got, it's a little hard to see, isn't it? But I've got a bunch of models and I'm just randomly putting them out, putting them out somewhere in space and spinning them around. And what I'm going to be doing is I'm going to be, over the course of this series, using various techniques to push that frame rate up, really. So currently we've got 419, 420 frames per second. And that is, what, with 1,000 objects? Let me just go into my config. 1,000 objects. So if I bring this up to 10,000 objects, we can see here we have 14 objects, 14 meshes basically, and I'm randomly creating a whole set of them. Bring that up to 10,000, let's see what performance we get. And something's really dark in this, but anyway, as you can see, we've got a whole bunch of objects and we're now running at 41 frames per second, which is not the best. Okay, so my goal with this series, if we can achieve it, is to get 1 million meshes on the screen at a reasonable frame rate, which is hopefully more than 41 frames per second. Can we do it? I literally do not know, but let's find out. So the first thing I'm doing is I'm coming in the middle of the series, so it's intermediate. So hopefully you should be comfortable to pop into the provided code and have a look and have a feel for how this is working. This is currently the sort of the start folder. Anyway, but really the big thing is I'm going to deal with textures. So the issue is that most of the techniques for dealing with big scenes involve lumping a large number of small objects into a small number of large objects. Get it all together in the same memory allocation. The GPU can do with it as it will. And today I want to talk about textures. So these things are all textures. And currently what I'm doing is something like this, right? So I've got a whole bunch of individual textures. And for every object has a different texture. So I say to the GPU, hey, you're using this texture, draw. Now you're using this texture, draw. And each of those operations is taking some non-zero amount of CPU overhead. So what I want to do instead is basically make a texture allocation which holds all of the textures as layers. So instead, it's like a whole stack. It's actually easier to visualize vertically, but it's easier for me to hold horizontally. So we've got like a whole bundle of textures. Each layer of that texture is an individual texture. There we have it. And what we do is, instead of binding these on the fly, we sort of bind it up front and we say, hey, there's your bundle. And then when we draw a model, that model includes information on which of these textures to use. So hopefully that will reduce the CPU count and we can get that frame count above 40 frames per second. Okay, there are a few steps involved. So the first thing, I think it's really good to be familiar with the files that we're working with. So here we are in the start folder. We can see here in the image folder, we have a bunch of these different images, and I'm going to try to load all these images in together as one thing. If I go to Here we go. Okay. If I go to my config header, I've got a struct here which defines all the info needed to draw a mesh. And we can see here that each mesh has its own material. So I'm going to get rid of that. We're not going to do that anymore. And I'm going to go to my factory, my model factory. And in my model factory, I have this load 2D material. I'm actually going to change this. So I'm going to change this to load materials, and we're going to take no info. And what this is going to do is it's going to look through that set in the config, because we have this set of file names, look through these, load them all in as one allocation all up front. So I'll pop over to my source file and I'll change this, get it out of the way. Yeah, we can get rid of this as well. We don't need that. Talking to myself. Okay, so the mesh does not need to load its own material anymore. Okay, so what I'm going to do is, first thing I'm going to do is generate a single material and allocate storage, because we know how many of these models we're going to need up front. So first thing I'll do is I'll generate the texture, then I'll bind it to work with, and I'll bind it to GL texture 2D array. These are called array textures, by the way. It's an array where, anyway, it's a bit of a loaded term, but anyway, I'm going to bind the material, so we'll work with that, and then I'm going to allocate storage. So I'll call GL text storage 3D. We'll have our texture target, and then the number of levels, map levels, which will be 1, and then the internal format, which will be RGBA 8. Then the width, the height, and the depth. So the width and height are the width and height of each image. Every image in this array must be the same size. And then we'll have the depth will be the number of images. So I believe that I've hard-coded all of these to 1024 by 1024, and then we go object type count for the number of textures that we're loading. Okay, the next thing I'm going to do is I'm going to loop through and load every texture. So I'll say for I going from 0 up to object count type, we'll then go and load everything. So for the file names, I've got this, So in config, I've got this unordered map, which defines, vector, which defines, okay, for every layer number, what is the file name that we should be loading there. So I'll look through there, load them in. That's probably fine. And then what I'll do is, once I've loaded this, I will blit it into the appropriate layer of my material. So the way I'll do this is GL text sub image 3D. So again, we'll have the texture that we're blitting to. So we can see pretty much this is what we need to stick to. So we'll have the target, then the MIP level, which will be 0, the X, Y, and Z offset. And this is the X, Y, and Z offset within the data that we're loading in. Then width, height, and depth. So for width and height, 1024. For depth is 1 because we're just loading one image. Actually, I changed my mind. I'm going to X offset, Y offset, the Z offset. I think these offsets are, they might be within the target So we're going to be pasting into layer I of the target. With height depth, format, RGBA, and then type. It'll be the same as this. Yeah, that's probably fine. That is probably fine. Just setting that up. Okay, great. So this function will now simply sniff through all of the files, load them in as a different layer, and then return the resource which has all of those images loaded in as one object. So now what I can do is I can go to my renderer and change it. So I'll go to the header for the renderer. That's the render system. And here, in addition to all of this, I'll have, we'll call this, the single material that holds everything. And then right in here, again, I can get rid of that line. Actually, yeah, okay, cool. So then right down here where I build the models, after I've loaded everything in, I will go ahead and get all the textures. So I'll say, almost said meth factory. That would be very interesting. No, what? Make mesh? Oh my goodness. I probably need to make that, probably need to make that public. So I'll go over, yeah, load materials. Everything should be in there. And then when it comes to rendering, this binding only needs to happen once right at the beginning. So we're not doing this call 10,000 times. We're doing that call once at the beginning. So bind texture, texture 2D array. We're going to bind our material. Okay. Now this is almost going to work, but I need to change a few things. We can probably run it and look at the interesting error that we get. It's a good thing just to run. Yeah, so we totally get an error. It's messed up. Okay, that's interesting. So what I'm going to need to do is I'm going to need to go to shaders, and I'll go to my fragment shader. And here this will be a shader, sampler 2D array. And then all I need to do is for a sampler 2D array, to sample from it, the texture coordinate must be 3D, because we'll need the, think of it like the X and Y component, but we'll also need to know which layer we're sampling from. So I'm going to go to this fragment texture coordinate. I'm going to change it to vec3, and I'm going to go to Vertex. So there are two ways to handle this. We've got our XY texture coordinate for our point. We also need to take in which object we're rendering. One way is to define this as a vec3, and then at the time when we load the model, to bake in the information at each vertex for what this thing is. Another way is to take that info in dynamically. I know that I'm going back and forth on this, but I'm actually going to take the vec3 approach. I changed my mind. Okay, because I'm thinking about, I'm thinking about life, I guess. No, I'm thinking about passing this in dynamically versus passing it in pre-baked. And even though the storage is a little more and it's not the best, we'll do this for now. Okay, so we're going to take in texture coordinate. We're going to pass out a texture coordinate. No transformation is going to happen along the way. And then over here in the model factory, when we make this thing, I'm probably going to need to jump in and change a few things. It's actually not too bad. So this function here, read corner, is the point. I'm going to change this actually. I'm going to change this. So anytime I see this vector. So what I'm doing here is previously I've been storing all of my info with VT being a vector of vec3s, a collection of vec3s, a vec2, sorry. But I'm just going to save it as vec3s, and then there's a little bit of jazz going on here, but then I'm just going to work with vec3s the whole way along. So right down here where I push in a new vec2, I'm going to change that. I'm going to insert, I think it's I, yeah. That's the object type there. So I know this is a little like, I'm being vague, but basically what I'm doing is I look in the file, I read in the XY texture coordinate, I then on top of that insert the object type which was given in the function here, make mesh. So we're just passing in some extra info. And then I'm going to need to be very careful because I've changed the stride of my elements. So for instance, this probably isn't such a big deal, but it's a good idea. Yep, we're now going to have 9 floats per, per thing. So then when I come down here to describe the attributes, every attribute, every vertex is now going to have 9 floats, 9 times 4, so 36 bytes. So then we come here for the texture coordinate. That has now got 3 components. It's going to start at an offset of 12, and then the normal is going to start at an offset of 24. I think that should be working. Let's find out. I think this is it. Bit of a weird error, but that's how it is. So it looks like I'm going through and I've got this redbrick.jpg, but this is a PNG. So it looks like all of these are PNGs. Okay, I really don't know how that happened, but I'll just go into my config and I'll change these so they're all, board.jpg works. That is very strange. Okay, I'll change it all so they're PNGs. See how that goes. So this is a little disconcerting because everything is loading with the same image. I guess the first image, right? What's going on here? It's being populated everywhere with zeros. That's sort of messed up. Let's look into that. By the way, I'm going to fix this camera as well while I'm at it. So I've go to the camera system and I create my field of view. I'm going to actually, double that. That should fix the camera a little bit. But, Model Factory, what are you doing? Okay. So, the issue is I've got a collection of vec3s, but then I'm extracting a vec2 based on that. And that is, by default, just... I mean, I'm lucky that it works at all. But I'll just put this in so that I'm definitely extracting a vec3 from my set of vec3s, and then I'm putting all its components in. Let's see what happens. There we go. That's much better. Performance is the same. Hey, what can you do? But yeah. Oh, and there's something I missed. No, I'm in release mode. Okay. Yeah, so interestingly, we have taken a hit. We've gone from like, what, 41 frames per second to 32 frames per second. So I'm going to try to see if I can change this. I'm going to try the uniform approach. So I'll grab my shader and I'll say, okay, instead of taking this in as an attribute, It's going to be the way it was before, and we're going to take it in as a uniform. And then I'll go ahead and construct a vec3 in the shader, putting in that thing. I wonder what difference, if any, this will make. And so I'll go to my model factory and I will change this back to vec2s again. Okay, so just undoing everything that we had. And then we'll go up here. Now we got, again, 8 floats per vertex. And I'll reset that stride and everything. So 32. Okay, that all seems fine. And then in the render system side, let me just have a look. Okay, so in my render system, I'm going to have a uniform which is tracking the object type that I'm sending to each mesh. So I'll just say I have an object type location which is pointing to that uniform, and I'll go ahead right up here and I'll do the same thing. I'll fetch that. And then in rendering, general uniform, one float, going to send to the object type location that object type. Let's see how that goes. I'm thinking it's going to be the same. Or maybe because I've gone from 9 to 8, it might be like a power of 2 thing. Oh, that's better. That's very interesting. And this sort of seems a little messed up, doesn't it? Yeah, no, something is definitely very messed up here. But that's okay. I reckon I can sort that out. It's going a lot faster though. Okay. Let's take a second and see what I've done here. So we're definitely pushing on 2 vertices. Oh yeah, okay. I just forgot to update that one little bit. It's keeping track of how many vertices per number. Or rather, how many floats per vertex. Okay. So as you can see, we have 6. This is a little bit of a strange thing to say, right? Because we've successfully achieved exactly the same performance as we had before. And that's sort of how it's going to go a lot of the time in this series. But the direction that I'm moving in is basically GPU-driven rendering. And in order to do that, we do need to implement a lot of these techniques, even though they may not necessarily have direct payoff straight away. But yeah, there we have it. So in this video, we went from binding textures on a per object basis to loading in a whole bunch of textures in one go and then sending in info about which object we were rendering. Okay, so I'm happy with that for now. I hope that you enjoyed. Wow, it's green. This is not the most realistic scene. Anyway, I hope that you enjoyed this, and it's going to get green again. I will see you again soon. All the best. Bye. Hi everybody, I just want to take a second to say thank you to all of my channel supporters. If you would like to support the channel, it's only $2.50 a month, that's it. But it really does help, even just in terms of motivation for me to make more videos. If you cannot afford to support the channel monetarily, that is totally fine. I do not expect it. The best thing you can do is pop on there, comment, let me know what sorts of things you'd like to see, and if there's anything I can do to improve the videos. I am trying my hardest to improve the videos, although it may not always seem that way. So, thank you so much to Antonin Carret, Dankil Foles, Declan, Endelon Studios, Isaiah Meyer, Jason Coleman, Matthew Derrick, Moim, Shreyar, Skibbity Pop, and Maxim Shukim. Thank you so much, my dudes. It means so much. Have a great day, and I will see you again soon. Bye.